Hi everybody, welcome to the grand finale of the IBIPSA education webinars on urban scale building energy modelling. Today I'm delighted to have Jérôme Kämpf and Dasaraden Mauree with us, who are going to be talking about CitySim and exploring urban building energy modelling in practice and its application. And so this webinar is part of the remit of the IBIPSA Education Committee, and the committee's job is to identify education and training needs throughout the building simulation community. And we initiate and develop new education materials and methods. And one thing that I personally am very proud of and feel very strongly about is that these training sessions are offered to non-members as well as members. But of course, we do invite you to join, and I will tell you more about that later. So the format of today's session is the same as we usually use. And if you've been to one of our webinars before, it will be very familiar to you. But in a minute, I will invite Jérôme to give his presentation. While he's doing that, you can put any questions and answers, any questions into the Q&A box. And then at the end of the presentations, I will put those questions to Jérôme and to Dasaraden as well. At the end of the questions and answers, I'll come back and tell you a little bit more about what's coming up next and how you can get more involved. So, thank you very much, Jérôme. And if you would like to share your screen and get on with your presentation, that'd be great. Perfect, I can see that well.
Perfect. So thank you, Pamela, very much for this very nice introduction. So hello, everyone. From my side, welcome to this education webinar about CitySim. So my name is Jérôme Kämpf. I'm from the EDIAP Research Institute and ChemCo, and I'm going to discuss a little bit about the tool CitySim, make a little introduction about how it was created, its key capabilities, and I'll try to answer in about 25 minutes, should be a little bit less, to these two questions: what is actually CitySim and how it can be used for research. And then I'll give the floor to my former colleague, Dasaraden Mauree, and he will talk a little bit about the case studies and the results. And in about 15 minutes, he will try to answer the question, how can CitySim be used in practice? So we tried to be really practical here. And well, hopefully you will also see that actually his face is not as squashed as what you can see on his picture on the first slide. So to start the introduction, I will just say a few words about myself. So originally, my background is in physics, but I have also a master in computer science and teacher education before starting a PhD at EPFL in 2005 on the modeling and optimization of urban energy fluxes. And actually, that was when I started the work on CitySim. After that, I stayed quite some time at EPFL doing research, leading the urban system simulation group before creating a company in 2013 called ChemCo for the distribution, maintenance, and training about CitySim. So I continued my work as a professor at the University of Applied Sciences in Fribourg for 2 years, and I joined in 2018 the EDIAP Research Institute. It's a research institute about AI, artificial intelligence, and I lead a group in energy informatics, which is related to all the AI for energy elements that we are developing at the moment. So EDIAP is associated with EPFL, so also a lecturer at EPFL. And my idea to show you that is just to mention that actually today I'm going to make in 25 minutes a little brief history of time, because I'm going to focus on the zone that you have on your screen between 2005 and now 2024. So almost 20 years of research, well, 19 years of research about CitySim. So you can see its evolution starting from only, let's say, an urban energy simulator to something that grew bigger and bigger with the years. And I'll end up showing you some illustrations of what we do now with my students in research. So to go back to the beginning, let's say, the history of time. So back in 2005, I started a PhD thesis with Darren Robinson, and the idea was to be able to start building an integrated solver that we named CitySim. So I was a big fan of SimCity when I was younger, and of course the name came quite naturally. And the idea was actually to take a couple of simplified models, such as a simplified radiation model, to be able to get for an ensemble of buildings the irradiance that you can get on the facades and on the rooftops, to actually get that quite fast, so that you can have on a hourly basis all the different values that you can get on the building shell. And to go a little bit deeper into the shell, we developed a simplified radiation model, so that with that we have, let's say, the solar gains that come into the building, so we can get the internal temperature of the buildings, and we can know or calculate what are the needs for heating and cooling inside the buildings. And we have linked, of course, that thermal model with occupants' behavior models, and we have also energy conversion systems. So for example, we have models for PV panels. So they will be irradiated, let's say, on the roof of the building, and then converted into energy, either heat that will be stocked in a heat tank, or the domestic hot water tank, or electricity that will be used for domestic appliances. So all these models are included in CitySim, and we have also, of course, models for heat pumps, for boilers, or for different cogeneration systems that you can integrate in buildings. So this was created at the time as, of course, a research prototype. So at the end of my thesis in 2009, we had the first version of CitySim out, let's say out, and it works exactly like Energy Plus. So it's a solver that is command line. So you just have to type CitySim, give it a scene description file that is in XML file format. So it's human readable. If you open this XML file, you can see different tags that define the properties of the buildings and all the information of the scene that you want actually to simulate. Then you run the simulation, you wait, of course, some time, depending on the time of your scene, and you get some results in text file format. So depending on the size of the scene, it can be quite big file formats. So then you need to use some dedicated programs to load these files and study the outputs of CitySim. So we have, through the years, continued its development, and we put it open source actually on GitHub. So you have the address here on the slide. It is under an open source BSD3 closed license, so that everybody can go and download it. You can include it in your own work, you can improve it, and so on. Of course, if you improve it, please help the community, so that all your developments can go back also to the other people. The idea behind this is, of course, that research and all these developments were funded by public funding. So the idea is to bring it back to the public as well at the end. And then we continued the developments actually with my first PhD student, Diane Perez. She worked on an integrated, not solver this time, but a web platform, so that we could use CitySim as a web service. So it has a front end where actually you can see the buildings, you can click on a building, you can see the information of the building, and you can click on a simulation button, and then you get the heating and cooling needs of all the buildings computed by CitySim. And you can, in the platform, play with different retrofit and supply scenarios. You can connect the buildings to district heating networks or to very simple boilers, and you can see the effect it has in the simulation of CitySim. So here I just showed two examples taken from the thesis of Diane. The first one is in Neuchâtel, so not far from my place, district heating network scenario. Basically, the question was, what are the buildings that are more interesting to connect actually to a district heating network? And the second one is the reverse. We don't want to heat, but we want to cool the buildings. But this is using the lake water. So we pump the lake water at about 5 degrees, and we want to distribute it to the different buildings around. And we were wondering which buildings would need this free cooling and which ones could be easily connected to the network. So we did all these simulations, but you see this was almost 10 years ago. So now we can see that we have all these kind of platforms around that exist and that can actually simulate very quickly all the needs and what we want. And then I had the chance to hire actually Diane Perez into my freshly created company, Kämpf, in 2013. So we've built together a graphical user interface to CitySim, which was named CitySim Pro, CitySim for Professionals. And the idea was within this graphical user interface to be able to see the buildings that you want to simulate, but not in 2D, but in 3D. So you can turn around the buildings, you can see the scene, and you can click on a building, you can see the properties of the building, you can click on a surface, you can see all the details, physical details, the openings and so on about the surfaces. And the idea was, of course, to be compatible with what architects and other designers use. So at the time, we were using AutoCAD DXF. So we added an import features for AutoCAD DXF so that then you can just get your scene, see it in 3D. And of course, you need a lot of physical information to run CitySim that are beyond what we can find in CAD files. So there we used default values for all the material characteristics when we import a scene. And then, of course, in the interface, the idea is that you can refine all these default values to get what to simulate your simulation. And then you can see in the interface with false colors the results on a hourly, monthly, or yearly granularity, time granularity, the irradiance on the facades, on the walls, on the roofs, and the heating and cooling needs, the solar panel production, if it's solar thermal or PV, and all this information can be seen in a very nice way. And what we can do also here with the interface, so if you think that this was like 10 years ago, at the time, it was very trendy, actually, to 3D print everything. So basically, what we did was to be able to export in STL format also the 3D models that you could load in CitySim so that you can 3D print it. So this is an example of one of my former students. She worked in some part of Italy. If you look at my picture, you could see a little 3D printed neighborhood of a city. And this is exactly what was really trendy at the time. So we had that export STL feature for making this wonderful 3D printed elements. And then we moved on to something a little bit different with Silvia Coccolo and her PhD thesis. Actually, we thought, okay, we can simulate buildings, we can simulate many buildings, so why not simulate also what is in between the buildings? So we added grounds to the scene, we added green areas, and we added trees. And the idea was to develop actually simplified models for the evapotranspiration effects of the trees and of the green areas in general. So we added all of this to CitySim. We ran simulations. Of course, we calibrated the models. We had a look at the different results. We compared with measurements. And then we studied here, especially campuses in her thesis. So the first one that you can see on the slide is DPFL campus in Lausanne. So it's a moderate climate. And the next one is the Swiss International School of Dubai. So in Dubai, hot and arid climate. So very, very different campuses. But the same idea is that it could be comfortable outdoors for the students. So here, what we also, additionally to the greeneries and trees simulation, we also added the possibility to simulate virtual pedestrians. So we added the equivalent of small buildings in the scene that should maintain a certain temperature between 35 and 37 degrees internally, with different layers of the fat, of the skin, etc. And with those small buildings that were pedestrian-like, let's say, or pedestrian-like buildings, we could compute the mean radiant temperature, and we could compute basically two comfort indices. The first one is the Confa star for moderate climates that we computed for the EPFL campus. And so we were able to do maps, and we could do maps of comfort and know how many, for example, hours of the year you can be comfortable in a specific location. And for the hot and arid climate of Dubai, we had to use another index, which was more suited to hot and dry climates, which was the ITS, so the index of thermal stress. And there we also had these small virtual pedestrians to be able to do the comfort maps. And what was really interesting is in Dubai was that actually we could monitor the whole facility for over 1 year. And with all this data, we could compare to our simulations. So we had very interesting work here with Sylvia, and we tried to integrate all of this work, of course, in the graphical user interface of CitySim, so that you can actually see the grounds, you can see the trees in the scene when you load it, and you can run your simulation, and you have some output files that can give you the comfort indices, Confa star and ITS that I mentioned before. You can see the mean radiant temperature, and you can have an idea of the urban heat island effects that you can have in cities by looking at the surface temperatures of the grounds. And we also further improved the import facilities, actually, so that we can import CityGML 2.0, we can import IFC, we can import geo-packages, because we have seen that different people use different standards. With architects, we could use IFC, and with people doing geo-information, it was more geo-packages and this kind of formats that were mostly interesting for them to be integrated in CitySim. So we also added the export in CityGML 2.0 plus the energy AD 1.0. So that was interesting to also output all the results of CitySim in a specific format that is compatible with other tools, so that you can load and compare with other tools the simulation results. And yeah, that's basically all the new developments that we did so far. And right now we are working on adding specifically two more comfort indices, but I'll tell you more about it after a few slides. In 2019, so we are getting closer to now, we started working on district heating networks. So in Switzerland, basically, the state wants to have a massive reduction in fossil fuel consumption, and one of the different ways was actually to promote district heating networks. And so we had a project to have a look at district heating networks and to see the potential of the integration of solar energy also in district heating networks for the whole Switzerland. So we had a couple of master theses, as you can see here: Pierre Cogniet, Cédric Serugendo, Pierre van Broekhoven, Maximilien Clapier, and basically they worked on first, Pierre Cogniet, the simulation of district heating networks within CitySim. So we can simulate tree-based or meshed networks, so any kind of complexity. Running the simulation, you can get in the different pipes the pressure, the temperature, the mass flow, and it's really interesting because you have the losses that you get in the grounds, both for the thermal losses, but also for the pumps that can be computed. So you know how much, let's say, electricity you lose to be able to push the water in all the pipes. And what is really interesting in CitySim is that you have the supply side computed by the building models, but the demand side, sorry, computed by the building models, and the supply side that could be provided by the district heating network. And here we wanted to see if we could have also the integration of solar so that not only the consumers could be consumers, but also prosumers. So if we could fit solar thermal panels on the roof of certain buildings and inject that heat in here, for example, in Yverdon, a low temperature network. And we wanted also to address the possibility to have seasonal storage in terms of big water reservoirs that could be below or nearby the central heating station. So we studied here a small network in Yverdon, and we had very interesting discussions also with the city and the energy services of the city of Yverdon. So how is CitySim used for research in general? So you have seen what it can do in a few slides, through many years of research, what we developed. So generally, in a standard way, we have people developing a CAD model. And the CAD model can be done, for example, here, it's an example made by architects. So these architects, they use ArchiCAD, and with ArchiCAD, you can export in IFC. And we were able to import the IFC in CitySim. So then it's fitted with the default characteristics, iDefault characteristics for the buildings and the surfaces. And then we refine those characteristics in the CitySim XML, and we can run the simulation and have this kind of wonderful color maps that can help actually the architect or the urban designer to think about how to improve the landscape, the urban landscape. So this is a very standard way, but you know that researchers are very, how to say, creative, so that at some point they like to use many ways the tool, even in ways that it was not thought of. So basically what we did at some point was to create a Docker on our GitHub so that people can Dockerize completely CitySim, use it as a web service for GIS, or they can use Python scripts basically to scrape data from different sources and to create a CitySim XML file that can be run within the solver or loaded in CitySim Pro, the graphical user interface, to be able to see the buildings in 3D and see the results of those simulations. But we can have also the Python scripts to read the output files and make graphs for publications, for example. And yeah, that's all the different ways, plus a very classic way to use CitySim, which is command line, which is my preferred way, but then I'll let anyone use their own preferred way. So just to show you some examples of research that we carried out in the last years. So this is a bachelor thesis of Ludivine Defago. So she used the very standard way. So basically she used SketchUp to do the 3D model. So she made the 3D model here of some buildings in the city of Zurich. She was able to get open data about the geometry of the buildings from the city of Zurich. And she designed the trees, she designed some shading elements, she designed the ground, and she also designed some small pedestrians. If you look closely at the central image of the slide, you will see some small elements, and those small elements, building-like, are pedestrians. And we studied the pedestrian comfort here under facade greening. So we tried to put some greeneries on the facade of the building and see the impact, of course, with the temperature that you can feel that is a little bit cooler from the greeneries on the pedestrian comfort. And we wanted also to fight a little bit climate change and to have a look at a campus in Sion, where actually it's facing south and you have a road that is completely mineral, and it's getting very, very warm there in summer. And she wanted, as just a test, to think what could bring to have this greening facades on the comfort of pedestrians, because she is going to that school, so she was interested to see how we could improve potentially the comfort around the school. Another example of using CitySim, but this time with Python scripts. So we have the master thesis of Olivier Chavannes. So he was interested to work with the company CSD on actually sizing DHL and making different scenarios of energy provision for the district heating network. So basically he used open data in QGIS and he built Python scripts to read all this data that you have stored somewhere in a geo package coming from QGIS to build a CitySim model of the buildings that you can see in the center of the slide. And he made a script to automatically create a tree, so the minimum spanning tree between the potentially connected buildings that are in orange on the slide. And then we could run a simulation with CitySim to get all the needs of the buildings. So we could size the pipes of the network and finally get some information about the hourly needs and provisions that you can get in the district heating network. He tested also some scenarios for different energy sources, such as wood, cogeneration, or to have heat pumps, for example, in the central heating station. And he had a look at different criteria, of course, economic, but also environmental criteria to be able to select which one seems to be the best solution. And last example, a master student that is actually suffering a lot. Of course, working with me is always a big suffering. He's working on an open source framework, but not only to work with buildings and district heating networks, but to add also the grounds to get an idea of urban heat islands and the pedestrian comfort that you can get in Switzerland. So basically, in addition to what we had before with Olivier, here we are using another data set that is called Swiss Alti 3D. That is an altimetric model of Switzerland that is at every 50 centimeters resolution, so a pretty dense one, to create the grounds around the buildings. So he has a QGIS model, file, saved under geo package. He uses a Python script to go to the register of building and lodging. So using an API, he's querying data, and then he is building the XML file for CitySim, running CitySim, loading the output files with a Python script to put them back in the geo package, and we can visualize all the results nicely and swiftly in QGIS with different colors. What is interesting here is that he's also using the Swiss TLM 3D model, which is actually a model of the type of soil that you have. So if you have water bodies, if you have greeneries, if you have a road, if you have pavement, all this information you have, and you can use it for building your model and running your simulations. So that's, I see that time is flying, so I have to start to stop talking. So where is it used, CitySim, and by whom? Actually, it's used almost everywhere in the world. You can see here a map that we made some years ago. We have more than 600 users around the world. We have some resources for these users. We have a book, and of course, a lot of publications, research publications about CitySim, how the models work, and so on. We have a guide to tell you everything about how to use CitySim from CAD models. We have a wiki. So on the wiki, you can see the whole structure of the XML file. So you can create your own XML files for CitySim. And we have YouTube videos showing you step by step how to go from a CAD model, actually import it in CitySim and running your simulations. But it's not only used for research, it's also used for teaching. So I have an invited lecture at EPFL where I actually show the students how to use CitySim, and they have some practical exercise. but it's also used by practitioners. And this is what I wanted to show you today. But as I'm not a practitioner, of course, that's why I asked Dasaraden Mauree to be able to show us how CitySim can be really used. Because for research, you know, it's always, yeah, it's nice. But can it really be used in practice by a consulting company? And he's also using it for teaching. So then, of course, I'll give him the floor for showing you all these different aspects that I do not cover. So Dasaraden, I'll stop sharing and
thank you, Jérôme. Let me just share my screen now. I hope everybody can see. Perfect. So thanks a lot, Jérôme, for the introduction, and also Pamela before. So my name is Dasaraden Mauree. I have a PhD in Earth and Environmental Science with a specialty in urban climate. And I've been working at EPFL before from 2014 to 2020, also with Jérôme very closely for a few years now. And this is how we started using CitySim. I'm now working in a private company, which is called WSP. WSP is an international consulting and engineering company. We are based in Canada, but we are also based in Europe, everywhere, in England, France, and in Switzerland. And there is around 600 people working in Switzerland, and we cover engineering works from infrastructure to the building aspects. But if you want more information on WSP, I'm very happy to give that to you afterwards. So today our idea was to tell you how we can use CitySim and how this is also helping us in the work that we are doing in urban areas, and in particular with urban adaptation. And I will start by telling you actually how we started working with CitySim. So the idea was to couple urban climate model with CitySim, because in CitySim, like Jérôme told you before, we can model very precisely the buildings, well, at least from an urban perspective and also from a neighborhood perspective. But we were lacking a little bit the impact of the local and urban climate. So we used a canopy interface model, which I developed in my PhD, where there is a basic representation of buildings. So you can see here on the left-hand side how the buildings are modelized, so very simplified cubic buildings that are one on top of each other for each of these vertical boxes that we have. And for each of these boxes, we then calculate fluxes that are generated from the building. So it's momentum fluxes, heat fluxes, humidity fluxes. So this is also interesting where we want to improve the integration of vegetation in urban areas. And then once we have the, I would say, modified urban climate variables, so wind, temperature, and humidity, we can then use that to run the CitySim simulations again. So what this does is this coupling is to be able to integrate the impact of the microclimate. So, and this helps us in two different ways. So first of all, to improve the computation of building energy demand at the urban or neighborhood scale, but also to improve the computation of microclimatic values for human comfort, outdoor human comfort, I would say. So this was the study that we completed in 2017 when I was working at EPFL. So we validated the model and the coupling with data that was collected on site at EPFL with the wind speed and the wind speed and the air temperature that you can see here on these two graphs. So the meteornorm one is the standard data that we would use typically when we are taking informational climatic data from a station, which is usually located outside of the city. This is the blue one. And then the orange one is the one that we would get when we couple the SIM and the CitySim model. So it's taking into account the drastic reduction in the wind speed in urban areas, but also the impact of the air temperature, as you can see with the urban heat island that appears during the, in particular during the summertime. So we did this comparison between the data that was simulated and the data that was acquired at EPFL. And then we also, I didn't show you here, we also evaluated the energy demand from the building at EPFL with and without the CitySim coupling. And we showed that there was an improvement in evaluating the energy simulation. So we can see here that this coupling was actually improving the outdoor, the climatic conditions that was simulated by the CitySim tool. Besides this coupling, then we went a little bit further. Now we know that this coupling was working. We tried to look at different scenarios. So the first scenario that was obvious for us to look at was the densification scenario. So this was an example of a simplified test that we did over a neighborhood that was in Nablus in Palestine. Because densification leads to a complexification of the urban heat island issue, with complexification with the reduction in solar gain, reduction also in natural aeration that we want to improve with mitigation scenarios for climate change. So what we did in this study is we evaluated two different scenarios. So densification scenario here. So we just looked at a very simplified one, of course, but the idea was to understand here until when we can use this type of coupling and how we can use it to make informed decisions. So I will now tell you some examples that we did at the consulting study, and you see why I showed you these two basically research approach that we had before and how it is now being used in the implementation in the consulting company. So at the urban scale here, you can see on the top image here. Sorry, I'm just going to get my mouse again. So this is the current scenario that we have in Geneva. It's a small neighborhood in Geneva called Les Vernets, where we evaluated the impact of the urban heat island here in this neighborhood. And we tried to look at how the vegetation could help reduce the surface temperature, improve the outdoor comfort, and then potentially reduce the urban heat island itself. So you can see here, there is a part where we evaluated, which was free. So there was no construction here, and where we could integrate vegetation. And then we simulated the same neighborhood for the future climate. So in July 2050, so without any measures, so without any trees on this spot. And we, you can see here that we added the trees. I'm sorry if we cannot see it very well, but we have added some trees here. And we try to look at how the impact, how positively they can impact the reduction of urban heat island. So we saw in this study that there was a positive impact of the implementation of these trees. Unfortunately, we didn't see a very big impact on the rest of the neighborhood. But there is also a river water flow here, which was impacting the whole neighborhood, which was so a combination of both the vegetation and the water was good measures. At the neighborhood scale, so this was also the relation to the densification part that I showed you before. This is an actual case study that we conducted last year for a neighborhood that is currently in design, so the master plan, where the architect and the urban designer had two different scenarios where they wanted to evaluate. So one where we have very rectangular buildings, and another one more dense and varied type of buildings. And you can see on the left-hand side here, this is the current surface temperature. So 2020, I would say, climate, and then 2050 climate. So the objective of the study was to evaluate how the building or the densification of this neighborhood would help, how we can help drive the design of the neighborhood by using tools such as CitySim in order to decide which scenario is best for 2050 climate. We saw that one of the neighborhoods, so actually it was the neighborhood here, where we have a more more diverse variety of buildings, that this type of typology of buildings was more resilient to the increase in temperature. And we can also see that in the middle, or actually in the center of these buildings, there are more there is less increase in temperature as compared to the other ones. We also then, I didn't show you here, we also then evaluated the impact of including vegetation in this neighborhood, and it was even more positive in this case. If we look at a more general neighborhood here, which we designed, so we try to include more diverse, I would say, range of sustainability, sorry, in our thinking here. So neighborhood-wide thinking, sorry, I'm going to get there. So what we did, sorry. What we did in this project, it's actually a building, two buildings, sorry, also in Geneva. We used CitySim very early on in the project with very similar approach to the slide that I showed you before in order to drive the design from the architects. And the idea here was to be able to position the building on this land, on this plot. And finally, what we decided with the architects, based on the surface temperature and also the outdoor comfort, was to have a square building here and a more rectangular building here in order to improve the outdoor surface temperature, to decrease also the overall urban heat island effect. We were also able to drive the water flow because how you can see here on this image where we don't have any trees on this top, you can see that most of the impacted land plot for the surface temperature was here and also on this side. So we also gave an input to the architects and to the designer into how the water should flow on the outside to be able to improve this. And also, of course, the vegetation, as you can see here on this bottom image. So in the end, what was also interesting for us here in this is that CitySim could provide very easily and very rapidly some information that are helping the designers very early on in the project for the positioning of the building on the plan, on the land surface, also positioning of the vegetation and also the water flows. So we were able to give this type of information to the architects. And finally, I want to conclude on, of course, we have seen from the beginning of the presentation and also with Jérôme how we can use it at an urban or neighborhood scale. But I want to highlight here that we have published a paper last year where we looked at regional scale, so European scale in this case. And we used CitySim to evaluate the energy consumption in different cities, 16 cities actually in Europe, to be able to evaluate the energy demand in the future. So we have been able to calculate the energy demand in each of these cities using some archetype buildings. Of course, cannot go into much details here, but what I want to say is that there is a use for CitySim also at this scale if we implement this correctly. And it was an interesting paper in the end because we have been able to look at how the energy demand is now, how it is going to change in the future, and what impact it will have also on the energy systems itself. So CitySim was basically the link to be able to do that and also evaluate multiple scenarios as well, whether it was median climate or hotter climate or low climate scenarios. And what is also interesting here is that there is a significant impact of urbanization and densification and the impact of CitySim in evaluating renovation scenarios, implementation of vegetated scenarios for the adaptation, with climate change is also going to be quite interesting for us. And as Jérôme said, I am also teaching. So basically training the engineers of tomorrow. We have been using CitySim in both courses. So it's a bachelor course on neighborhood and sustainable development, and one which is more focused on cities and driving future cities, sorry. And in both courses, we try to integrate the use of quantitative data and simulation analysis for the student, and basically we want them to be able to integrate these simulation tools in their project and compare them, of course, with data that has been collected on the campus or in their case studies. So thank you very much. I think we are almost on time, and we are very happy to answer your questions. And thank you.
Thank you both. That was fascinating. If you've got any questions, please use the Q&A box to type your questions, and then I will put them to Jérôme and Dasaraden. I'd like to ask first, the scale of the final study that you were showing, the regional evaluation, was really impressive. And I wonder how much processing power do you need to run those simulations? How long does it take, and what sort of resources are you using?
Yeah. So there, in this particular study, we had 3 climatic models that were basically coupled with each other. So it does take a little bit of time. The sim model for each case study takes about a day to run. And the CitySim one, something like 1 hour, an hour and a half, depending on the city. So it was quite rapid. But the climatic model, of course, are the one that takes much longer to run.
Yeah, thank you. And do you see in future integrating all of these aspects? So you're looking at the heat networks alongside the climate model and the future climate, as well as the building energy demand, an integrated future, I guess.
Yeah, maybe Jérôme can comment on the heat network part, but for us it would be obviously very interesting because although it's not really compulsory right now in Switzerland to take into account future climate, this is becoming an increasing remark, especially for designing heat networks and cooling networks as well. So it is interesting for us to have this input data and this integrated models, because then it basically saves time, and it's also cost saving because we're already designing for future climate.
That's going to, again, require quite a lot of processing. So are people able to run these models themselves just on a laptop, or do you need to run it using cloud computing, for example?
Jérôme, if you want to go answer. For CitySim, I think it runs on a laptop. For me, it's run on my laptop. For climate model, you need a server.
Yes, indeed. Quite all on the laptop, but when we do, if we want to do sensitivity studies on some meters, for example, or if we want to do calibration, if you have monitor or want to make them possible to actual monitoring, then you.
I think, Jérôme, you're breaking up a little bit for me. Is it the same for you, Dasaraden?
Yes, we cannot hear you.
No, okay. I think there's maybe an internet connection problem there. So do you see CitySim being applied in all sorts of different climates then? And is it coping as well, say, in a city in South America as it is in Europe, where you've started working?
I think we've lost Jérôme, but I will try to answer.
Thank you.
We have been using CitySim in different. There are a lot of case studies as well in different parts of the world, so I think it works very well. And basically, I think what is interesting with this CitySim is that finally the way it works is physical equations, processes, and where you can just input the data file from your own city, and the processes then afterwards are pretty much the same. So it works very well in different areas. That's our understanding, sorry, and we have been able to compare the data from different countries. So Jérôme was talking about Dubai before. We did in Switzerland. We also did in Palestine. So in a few countries, I would say.
That's really exciting to have such diverse case studies. Now, we've lost Jérôme, so I hope you don't mind if I ask you some of the questions that have been popping up in the Q&A, which are some really great questions. So thank you, everybody, for those. So the first one that I'd like to ask you is a very visionary question. So what do you see as the future of CitySim?
I'll try to answer that instead of Jérôme. I don't know if he can. I'm sure he will maybe be able to complement. But from our side, I would say from a consulting and engineering perspective, CitySim already provides a huge variety of answers in terms of outdoor comfort, I would say. Integrating also directly the calculation with indices that we typically use in this aspects. And maybe this is then an issue with the respect of how they do apply for the rest of the world. Because of course we know that these indices have been usually designed for European or North American countries. So we have to handle this with care. But also now with the integration of district heating and the development that is currently done by Jérôme, this is definitely where the future of CitySim, I would say, lies.
Thank you. The next question is a very targeted one about modelling the building energy demand. And it is asking whether CitySim considers each building as a box as part of the UBEM, or are they in fact divided into multiple thermal zones?
You mean in CitySim or when it is coupled?
In CitySim, I think.
Okay. And the second part of the question was how many?
So is each building a single thermal zone in CitySim, or
Yes.
does it have multiple thermal zones?
Oh, okay. So one building is a thermal zone. Typically, we would do that. But if it is possible to also discretize each floor, as one zone. So you can also do that if you want to have more precise energy calculations. So it depends on how, I would say, if you are very early on in a project, like I showed before, when you are doing urban design, you don't really need this level of detail because this would just complexify and add computational time. But if you are looking really into the energy simulation and you want to have energy simulation at the building scale with a very high precision, then you would want to have these zones discretized.
Thank you. That's impressive to be able to accommodate both. I would love to ask some follow-up questions on that, but there are too many in the chat I've had my turn. So instead, we'll move on. And the next question is asking whether the environmental simulation and the district heating simulation are separate software components or features, or are they always simulated together?
They are so the part of the district heating is integrated in CitySim. So this works with the XML file actually. But there is also additional, I would say, components that are now in open access with the Python libraries that are on the GitHub of CitySim.
Fantastic.
And also, then there is the part which is on QGIS. Oh, Jérôme is here, so I'm sure he will be able to answer this more precisely.
Hi, Jérôme. Welcome back. I think I will move on to the next question while Jérôme is connecting. Sorry, it looks like you've had to join from your phone. But thank you for that. So the next question is asking about whether there is an option for integration with software like Rhino and Grasshopper. So perhaps that's one for you, Jérôme.
Yeah.
Yeah, sorry about the connection. Actually, I had to call you back from my phone. I think the landline is dead, but can you hear me right?
We can hear you fine, yeah.
Okay, perfect. So yes, Rhino and Grasshopper, we had a former colleague, Giuseppe Peronato, who actually worked on building a bridge between Rhino and Grasshopper and CitySim. So if you look up for his name, basically on the web, you will find that he built a little a tool to be able to use actually directly your model. So if you have a model in Rhino, you can use it and connect it to CitySim. But at the moment, he was only interested in the radiation, actually. So his tool is basically connecting for the radiation on the building surfaces, but it could be extended. You know, it's a free world, so the code is open source, and people can download it and improve it. So if you want to use also other type of results, such as the building consumption for heating or cooling, or the district heating network, or whatever, I mean, this code can be improved and extended. And I think Giuseppe would be very happy as well to see that people use his code and improve his code as well.
That's brilliant. The recording for this webinar is going to be put on YouTube, so perhaps we could, if you're able to share me the link for that code, I can add that to the information on YouTube, and any other links that might be useful for people wanting to explore more. That would be great. Thank you. So I think the next question, which will have to be our final one, it's a two-parter, is asking about the application of PV on shaded surfaces, such as covered parking areas. And they want to know if they're modelling the parking as a building, should they apply PV on the roof layer?
So basically, if we have elements in the city that are not buildings, such as, I don't know, covers for the parking spaces, or bus stops, for example, that you want to fit with PV, you can use just what we call the shading surface, so that you don't have any thermal calculation or complex calculation that is done on these surfaces, and you can fit those surfaces with the PV. But the PV results won't be associated with any building. So of course it cannot cover the consumption of a specific building. So if you want, I mean, you can just identify that part of the building as shading, but put it in what we call the tag of the building. So like a building part, if you want. And then those production will be shown actually as a part of the building itself. So you don't necessarily need to build the shading itself as a building, but you can tie it to an existing building that is nearby, for example.
That's great. And that means you can look at the self-consumption, for example, I guess, which is going to be really interesting. So the final part of this question, I think, is perhaps for Dasaraden, asking whether you might use CitySim Pro in place of NVMet, for example, with the coupling with Sim.
Yeah. I think for us, this was also a big discussion in the beginning when we tried the coupling with with CitySim, and in the end, the answer was pretty much we have to go with CitySim because we can get year-long evaluation, which is more difficult to do with NVMet, and it then creates a better representation of what we want to do if we want to make a place more comfortable for all year long. So I think it provides, of course, the how to say, the discretization in CitySim is much less than what you will get in NVMet. I think it's a bit of a compromise between what you can analyze and what you will get. But it made sense to use CitySim for urban design.
Brilliant. Thank you so much. I'm afraid that's all we've got time for. There are a couple of questions that are still outstanding, and we'll try and give some information on that in the links, which will be on YouTube shortly. I'd just like to say thank you very much to everybody for coming, and thank you particularly to Jérôme and to Dasaraden for their time today. Before we go, though, I'd like to tell you about what's coming up next. So firstly, I'd like to announce a brand new webinar, which is going to be happening on the 20th of June. There's a QR code you can use to sign up for that. And this webinar is about in situ measurement and model calibration, and it's a study of the future home, which is the Energy House 2.0 building that you can see here in the picture, which is at Salford University. So we have 3 colleagues who are going to join us to tell us more about Energy House 2.0, the work they're doing more generally, and the case study as well. So do look out for that. And then we have the final 3 webinars in our occupant-centric simulation-aided building design series. So you should be able to see the QR codes for these. You'll get the sign-up links for these in your email that you get after this webinar, and you'll be able to see them on YouTube, and they're also shared on LinkedIn as well. If you can't see them, it might just be because the video panel is sitting on top of them, so you could move that and then you can see them. But we have 3 final webinars looking at advanced methods for occupant-centric building design, then looking at building interfaces, and finally looking at the sequence of operations for occupant-centric controls. So do please join us for that, and remember that all of those webinars are based on the book Occupant-Centric Simulation-Aided Building Design, which is available to download for free online as well. So if you missed any of the previous webinars, then do have a look at YouTube. The channel is at IBIPSA University, and you will find virtually a full curriculum in building performance simulation at the urban scale, at the individual scale, as well as lots of special topics of interest. So do check it out. We've got around 60 videos on there now from the various seminar series, and if you subscribe to the channel, you will be able to get notifications about new content as it's added. And you can also join the conversation. A lot of our discussions take place on LinkedIn. That's usually where we share the information about the webinars first. So if you're not already a member of the group, do please join us. If you've got ideas and suggestions for future webinars, do get in touch on LinkedIn and tell us what you would like to see. In particular, these later webinars on the tools for urban scale simulation came out of user requests, audience requests for some more targeted tool-based talks about urban scale simulation. So do let us know what you would like to see next. And finally, don't forget that you can always join IBIPSA as a supporting member. So these are the members who support the very good work of IBIPSA. And in return, they receive a print subscription to the Journal of Building Performance Simulation or online access to the journal. And they have the right to use the IBIPSA supporting member logo. The fees are very reasonable. They remain unchanged since 2019. And you can find out more about that at ibipsa.org/membership. So that's all from me. Thank you very much to Jérôme and to Dasaraden for your really incredibly inspiring presentations. And thank you very much to the audience for the great questions.
Thank you.
Thank you.
Thank you, Pamela. Thank you all for watching.
Bye.